Okay, so let's do number 9. A very similar problem to number 8. Okay. Now I told you for number 8 that since there was this one had this quadratic that had an a of negative, okay, that I knew that the quadratic, that middle quadratic, was gonna be concave up. This one, we have a positive a, which means that the graph, I can just kind of make an assumption that with the vertical asymptotes that we're going to have a concave down parabola and then we're going to have something like this. Okay. And these are the kinds of things that I want you to figure out. I want you to figure out doing enough of these. Hey, Miss Alstrom, did you notice this? Okay. So for this problem, once again, the vertical asymptote. And you will. I have full faith that you will figure out these kind of little patterns. And the horizontal asymptote is going to be the property of the rational function. To find the vertical asymptote, okay, I'm going to set that denominator equal to 0. So 3x, factor out the 3x, x plus 3 equals 0. So x equals 0 and x equals negative 3 are my vertical asymptotes. X equals 0, x equals negative 3. Using the properties of rational functions, we know that the horizontal asymptote is going to be y equals 0 because that's a constant. Woo! Guys, okay. So after that, I figured that out. Let's go ahead and graph it. Zero and negative 3. Y equals 0. Let's test some points. That's less than x equals negative 3. Let x equals negative 4. Which is going to equal 1 over 3 times 16. Three times 16 plus 9 times negative 4. 1 over 12. Okay, so once again, it's going to be positive, just like I had kind of guessed. So this side is going to be positive too. As we can pick x equals 1. 1 squared plus 9 times 1. 1 over 3 plus 9. Well, what do you know? Those two points are going to be the clear symmetrical points. Okay, now let's go ahead and find that midpoint between 0 and -3. That's just going to be -1.5, right? Because half of 3 is 1.5, and we're going in the negative direction, so that's going to be -1.5. So it's going to be -1.5 somewhere here. Whoops, I had some technical difficulties. Uh-oh. Still having technical difficulties. Am I recording? I guess I was recording. Okay. So we're going to let x equals -3/2. And that means y equals 1/3 times -3/2 squared. Oh gosh, sorry. Ugh. And that means that it's 1/3 times 9/4 minus 27/2. That equals 27/4 minus 27/2. That's going to be 1/. Gosh, Salstrom, what are you thinking? 27 times 2. Do it in my calculator real quick. 27 times 2 is 54/2. That is going to be 27, -27. Man, it's really hard to do these kind of problems. It's just late at night. I'm doing math all day. Sorry. So that's going to be 4/-27, right? So that was -3/2, comma, -4/27. Okay, so it's going to be somewhere right there. We'll just say. I think -4/27 is like -0.148. It's going to be closer to the 0, but just so that I could show you. So this little area right there is not covered. Okay, so that's going to be between 0 and -4/27. So that has to be excluded from the range. Okay. Zoom out. Zoom out. Okay. Once again, technical difficulties. Okay. I'm going to rewrite this over here. So the domain x such that x cannot be equal to -4 and x cannot be equal to 0, and the range is going to be y such that y is going to be less than or equal to -4/27, or y is going to be greater than 0. Whew, took forever. Okay, number 10. Now we have a quadratic, radical, and a rational function. Once again, the asymptotes come from the rational function. You start learning about asymptotes in rational functions, and then you learn about it in logarithms, logarithmic functions, and exponential functions. But you really don't see it in square roots. And you really don't see it in quadratics. Okay, so I'm going to take that take the vertical asymptote by setting that denominator equal to 0. Okay, and let's go ahead and factor. It's going to be a plus and minus 4x. Let's try 4x. And I've done this problem so many times that I think I know it's 6 and 9. Negative 24 and 9. And so x equals negative 9 over 4. X equals 6. X equals 6. And x equals negative 9 over 4. If I take the radical out, it's going to be 1 over this quadratic. What you've known so far with quadratics is that you're going to have two asymptotes somewhere, and the vertical asymptote. And then you're going to have, since this is a is greater than 0, you're going to have the parabola part be underneath, and this part kind of go like that. Okay? So we know that it's going to look like that. But what happens if you take the square root in? If you take a square root of that, and we know that x is now further restricted. Okay, now x was restricted by the fact that it was a rational function. X is further restricted because it's a radical. It's a radical. Okay, now how does it restrict it? It doesn't even just deny itself of that one number or two numbers that x cannot be, or x cannot be something. But what a radical does is create a whole range of numbers, okay? Because that entire radical cannot be less than or equal to 0. So if you think about it, the output cannot be less than or equal to 0. So what does it eliminate? It eliminates this part. When we know that this is y equals 0, it eliminates that bottom parabola. Okay? So we know that we're just going to have these two wings. So we need to find that. Okay? We need to find that. Now, let's go ahead and identify the horizontal asymptote. Horizontal asymptote is y equals 0. Okay? Now, notice what happens to the domain now. When we cut that middle parabola thing out, it gets rid of it. That x is no longer there anymore. So what I could do is on the number line, we're going to graph this eventually. And I'm going to test out these 2 points. And I just realized that I factored incorrectly. I think that's going to be a plus 6. And that's going to be a minus 9. Is that right? Okay. And yeah, I'm really doubting myself on all of this because I'm getting to the state where I'm tired now. You know what I'm talking about. Times 6 minus 9. Okay, so let's change these. Equals 9 over 4. X equals negative 6. Nine over 4. Okay, so let's go ahead and test these without actually graphing it. Let's go ahead and put something that is less than -6 into here. Now, my hypothesis is that it's going to be greater than, okay? And we want these to be greater than, because when we're looking at the domain, oh, I forgot to add this. See, I'm getting tired. When we're looking at the domain, the entire radical for x squared plus 15x minus 54 has to be greater than or equal to 0. But this entire thing cannot be equal to 0, can it? No. I forgot to do this part. 4x minus 9, x plus 6 has to be greater than 0. And that's where we got those numbers that we need to test. And we could just test the asymptotes. Okay, so when I put -7 back into the equation, let's x equals -7. So we have 4 times -7 squared plus 15 times -7. And all we're looking for is that we get a positive number underneath. And we don't really even need this. So that's going to be 49. 49 times 4. And then we're going to get -54. So okay, 4 times 49 plus 15 times -7 minus 54 is 37. It's a positive number. So we know that this is going to be positive. It satisfies the greater than. Oh, I shouldn't put that because it looks like an equal to. It satisfies that. Okay, now let's try a number bigger. I'm going to, I don't know. I'm just going to put 1,000. Okay, because why not? If I put 1,000 underneath here. Okay, if I put 1,000 right here. In this. 1,000 times 4 is going to be 4,000. 4,000 minus 9 is going to be a positive. That's going to be a positive. So this is going to be a positive right here. If I test 0, right here, x equals 0. If I test that, okay, what's that going to be? When this is 1,000, this is 0. So that's going to be 0 negative, and that's going to be a 0 positive. So it's going to turn into a negative. That doesn't satisfy it. It doesn't satisfy it. So we know that the domain is going to be x such that x is less than -6 or x is greater than 9/4. Just like that. Okay, before we find the range, let's start graphing this. -6. Nine over 4. What's 9/4? 2.25. Yeah, we kept on getting 2.25s. What's up with the 2.25? Okay. And then the asymptote we define, horizontal asymptote y equals 0. Okay. Now, we've already said that this is going to be a positive underneath the radical. And if I look at the rest of it, there is no negative that makes this negative, that radical negative. So I know that if the entire radical inside is going to be positive, it's going to be a square root of a positive number, which is a positive. And there's nothing to make that negative. So I know it's going to be some kind of positive number. So I'm just going to draw a sketch right here. And you can pick actual numbers, but I don't feel like it. Okay. Now, if I put in a 0, let's look what happens. Okay, if I put in a 0 to here, that goes away. Whoa! Isn't that something that we've already kind of assumed that that's going to turn into a negative? So this whole area between here, the two asymptotes, is going to be undefined for the domain. if I put in a number that is greater than x equals 9/4, okay, like 1,000. If I put 1,000 here, which I did right here in my example right here, okay, then that means that it's going to be a positive number. So I'm just going to draw my little rinky-dink graph. It doesn't have to be precise. There's my graph. What is the range of that? Y has to be greater than 0. Now, you should have known that since this is a radical, the range kind of takes care of it. Okay, the range is going to be, because of that is a radical. Okay, that there's, because of the fact that, you know, when we look at a square root function, the parent function, look at it. The y is going to be greater than or equal to 0. And because it's a rational function, it eliminates that equal to. But because it has the property still of a radical function, it's going to still have that same range. There you go. Good job, guys. Okay? Next one. Oh. So I've decided that maybe I'm not going to put partial fraction decomposition into the quiz if you're watching this. If it shows up, maybe I'll make it a bonus. Why not? Okay? So, because I put 2 hard problems on the study guide, and it's not fair. But I might put one of these as a bonus. Yes, good idea, Miss Alstrom. And now you know about it because you're watching this. Look at the perks. Okay, so let's go ahead and factor the denominator. X minus 16, x times x plus 4, x minus 4. There you go, there you go. Now this is going to be a over x plus b over x plus 4. C over x minus 4. And you can thank Sham for not having a partial fraction decomposition, not on your quiz, and having it be a bonus, because he came in, he said, you put 3 cubics as the examples. Why couldn't you just put a quadratic like the one that you showed us? And he has a valid point. Okay, so that's why I'm making it a bonus problem. Okay, and then if you watch the video, now you know. Okay, so let's go ahead and get our denominators, common denominators, just like that. And what is this denominator missing from that common denominator? We have an x plus, we need to multiply it by x plus 4, x minus 4. Okay, so that's going to be x squared minus 16. B needs to be multiplied by x minus 4. So that is going to be x squared minus 4x plus c, which is now missing x and an x plus 4. So that's going to be x squared plus 4x. Okie dokie. Okay. This is going to be 5x squared plus 40x plus 16 over x cubed minus 16x. Okay. Now I'm just going to take that numerator and I'm going to set them equal to each other. A times x squared minus 16 plus b times x squared minus 4x plus c times x squared plus 4x. Let's go ahead and simplify. Ax squared minus 16a plus bx squared minus 4, let's see, bx plus cx squared plus 4cx. Gather up all of the x squares. Ba-bam, ba-bam. Ax squared plus bx squared plus cx squared. Gather up the x's. And that's a minus 4bx plus 4cx. And then we just have that single one right there. Constant. Factor out the x squared. So we have a plus b plus c. This is going to be a 3-variable equation. Nice! Okay, let's take out a, I want this to be a plus. Okay, I want to take out a plus x. We have a minus 4b plus 4c. And then we have a minus 68. Okay. Now this is going to look like 5x squared plus 40x plus 16. Now, let's see what is common. I'm going to use some pretty colors for this. We have an x squared here. We have an x squared here. So that means that the 5 and a plus b plus c are going to be equal to each other. So that's our first one. So 5 equals a plus b plus c. Okay, second, we have an x here and an x here. What's being multiplied to the to the x? Okay, I'm going to have to find a different color, purple. Purple plus 40 and this right there. So that's going to be 40 equals negative 4b plus 4c. I'm running out of space here. I'm going to erase this. 40 equals negative 4b plus 4c. Now all we have left over is that 16 is going to go with this constant right here. And this is not that hard because look, we're only solving for one variable right there. Okay, so we have 16 equals negative 16a. Divide both sides by negative 16, a equals negative 1. Okay, a equals negative 1. Let's go ahead and put a equals negative 1. So our other equation that had the a, negative 1 plus b plus c. Put it into this equation right here. Okay, and then that is going to be 6 equals b plus c. 40 equals negative 4b plus 4c. So solve this for b. B equals 6 minus c. Okay, let's go ahead and put it into negative 4 times 6 minus c plus 4c. 40 equals negative 24 plus 4c plus 4c. So that's going to be plus 24. And that's going to be 4 and 64 equals 8c. Divide both sides by 8. C equals, oh goodness, what's 64 divided by 8? I'm so bad with multiplication. 64 divided by 8. Yes, it's an integer. Yes. Okay. Now we can put it back into one of our other equations. So C equals 8. Okay. And then next I can put it into, I could put it into the first one. So 5 equals 5. Yikes. Don't like that. 5 equals -1 plus b plus 8. 5 equals 7 plus b. B equals -2. Yay! There are my 3 that I'm just going to box because there's so many things on here. And then going back to where, therefore, now what was A? -1 over x. And then what was B? -2 over x plus 4. But we have to put it in the right way, okay? We have to make sure that we get their ABCs right. And then plus 8 equals 5x squared plus 40x plus 16 over x cubed minus 16x. Okay? Good job, guys. And then we have another one. Why, Miss Ostrom? Why? I'm going to factor this. I think I'm going to factor it by grouping because there's 4 of them. So take out x squared, we get x plus 1. Take out a -4, you get an x plus 1. That is an x squared minus 4, x plus 1. Okay, further factor it by x plus 2, x minus 2, x plus 1. Okay. How many more do I have? Oh, I still have a ton. Okay, so I'm gonna have 6x let's see, x, and then x cubed plus x squared minus 4x minus 4 is going to be a over x plus 2 plus b over x minus 2 plus c over x plus 1. Okay, now that's going to be x plus 2, x minus 2, x plus 1. And I need to multiply that by x minus 2, x plus 1. So a times x minus 2, x plus 1, plus b, so that's going to be x plus 2, x plus 1, plus b times x plus 2, x plus 1, plus c, and that's going to be x minus 2, x plus 1. X minus 2, x plus 1. Woo! That's going to be equal to 6x. Oh, I hear my dog. Okay, so let's go ahead and we got 6x equaling a times x squared minus ba-bam, 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 minus x minus 2 plus b, and then x squared plus 3x plus 2 plus c x squared minus x. Huh? How could those two be the same? I did something wrong. That one is missing x minus 2, x plus 2. That one is missing. No. No, Miss Ostrom. X plus 2. X plus 2. That's 4. Okay. Oh no, why do I even doing that? What did I do? What did I create? I created a monster. I have an ax squared minus ax minus 2a plus bx squared plus 3bx plus 2b plus cx squared minus 4c. Okay? This is going to all equal x squared. So I'm going to gather up ax squared plus bx squared plus cx squared, and then minus ax x plus 3bx, and let me see, let me color code these. So we had the x squares, and then we had the ax, bx, and then we are going to have the minus 2a plus 2b minus 4c. 6x. Take out an x. We'll take out an x squared. We get a plus b plus c. Take out a plus x. I'm going to make ax plus 3b. And then this entire thing. Okay, now we need to fill in the left-hand side. 0x squared plus 6x plus 0. Okay, that is going to give us a plus b plus c equals 0. Negative a plus 3b equals 6. And then negative 2a plus 2b minus 4c equals 0. That looks like the only one that I really want to target. Or we can do systems of 3 variable. Can I even solve something like that? Well, I can. I just have to use my 3 systems of equations. So I'm going to group the... Whoa. Okay, I'm going to group these two together. And I could just add them together. And I end up with a 4b plus c equals 6. And then I'm going to take that equation and multiply it by, or I could take that first one and multiply it by 2. Multiply it by 2, 2a plus 2b plus 2c equals 0. Okay, and then that is going to give me, that's going to eliminate a. So 4b minus 2c equals 0. And then I can just multiply this by a 2. So that's going to give me an 8b plus 2c equals 12. 4b minus 2c equals 0. That's going to give me a 12b equals 12. So that's going to be b equals 1. Oops. Got my b. Okay. Now, I'm going to use this equation right here. And I'm going to use negative a plus 3 times 1 equals 6. And so 3 minus 6 equals a. So negative 3 equals a. Okay. Now I can put it into anything. I can put it into my first equation. I can put it into this one right here. And negative 3 plus 1 plus c. That's negative 2. Okay. Plus c equals 0, c equals 2. Okay. And there that is, right there. Okay. I got my A, B on site. So, therefore, a negative 3 over x plus 2, b plus 1 over x minus 2, plus c 2 over x plus 1 is the same as 6x over x cubed plus x squared minus 4x minus 4. Okay? Good job. Once again, guys, okay, this kind of partial fragment decomposition is going to be bonus on the test. Look how much room I took to just bled right into my absolute value quadratic. Okay, so number 1, there is a typo. This is not factorable. Okay, I made a typo somewhere. Okay, so we try to figure out in after-school tutoring what Miss Hallstrom was thinking. What was the typo? So everybody said change that to 4, and it's factorable. But I don't think that's it either. Okay? No, I don't think that's it. Okay? So I have a feeling that that is 24. Okay? So let's say if I took y equals x squared. And I moved it, let's say, down 4. The parabola, I moved it down 4. Okay, so you know that it's going to look like 1, 2, 3, 4, down 4 like that, right? And then I took an absolute value of it. So that means all the output, all of this output right here, okay, that was a negative, is no longer going to exist. In fact, they're going to be turned into positives. So once I figure out my x-intercepts, which is x equals plus or minus 2, all of the stuff that happens is just going to get reflected over the x-axis. So instead of a negative 4, it's going to be a positive 4. And that's what my function is going to look like. That's all a quadratic, absolute value quadratic function is. I went downstairs and got myself a Haagen-Dazs ice cream. I think I deserve a treat. Hold on. Let me get my glasses. Okay. Now, so if I need to graph this quadratic, seriously, this is why I can't monetize these videos. It's only for my students, only for you guys. Let's go ahead and factor this. Ba-bam. This 24, I could factor out a 3. I finished my Haagen-Dazs. I think that's right. You get to a point where you kind of get exhausted. Once again, I'm doubting myself. Okay, and then factor that. We're setting these to equal to 0. That's 4, 2. Okay, and those are going to be my x-intercepts. Okay, now let's go ahead and find the vertex. I don't know why the kids that were tutoring this afternoon that figured out that this is actually 4. Couldn't figure out the axis of symmetry. They were getting a funky number. Probably because we were all tired. Three times 368, so -3. By the way, I do my multiplication in Korean. That's what you hear me say when you can't understand me. And then let's put it back into the function. F of -3 equals 3. Notice I'm just treating like quadratic. -3 squared plus 18 times -3 plus 24. 9, 27 minus. Notice that I'm going for my calculator. -54 plus 24, 27 minus 54, -3. Somewhere like -3 in there. But remember, okay, if I make a little table. Okay, so we had -4, 0, and -2, 0, and -3, -3. But look what there exists. An absolute value on this y. So I need to take an absolute value. So that's going to just change my output to a 3. So where there was the x-intercept and where this graph went underneath, that y equals 0. Now I have to reflect it, and it's now -3 and 3 right here. So it's just going to look like this. Just like that. Okay, so the domain of this, all real numbers, x, so that x is a set of all real numbers. The range is now, because it's an absolute value function, y, such that y is going to be greater than or equal to 0. Easy. That's not that bad. Okay. it says solve the absolute value equation and then graph. So 5/2 absolute value of 2 minus x squared. Now, to solve it, we just take the plus or minus of one side. And that's going to be 5/2 minus x, or negative 5/2. Distribute that negative through. And I just took this negative and I just distributed through. Okay? Now, somebody was asking, Nikita was like, Ms. Oster, I don't want to solve fractions. So just multiply the whole stinking thing by 2. That denominator. That's what I'm going to do. So that's 5 minus 2x equals 4 minus x, or negative 5 plus 2x equals 4 minus 2x. Okay, and then let's go ahead and 5 minus 4 equals 2x minus x, so x equals 1. Huh? Oh, why did I get x here? Okay, and then we have a 2x plus x equals 9. 3x equals 9, so x equals 3. Okay? So those are going to be my points of intersection. Okay? We need to split that up into 2. Y equals, so value, and y equals 2 minus. And one thing that I didn't talk about is that to find the y values, we can take x equals 1 and x equals 3 and put it into one of them. And it should give you the y value. And the y values are going to be the same. And so that's going to be 5/2 minus 1. So that's going to be 3/2. So 1 and 3/2. And I can put it in here if I wanted to. 2 minus 3 over 2. And what is that? 4 1/2. 4/2 minus 3/2. And so that's going to be 1/2. So that's going to be 3 over 1/2. So 1 and 1/2 and 3 and 1/2. So let's go ahead and graph those functions. So I'm going to take the first one, y equals the absolute. I'm going to put it in this form right here. It helps me see things. And then that now becomes, I'm going to take that negative 1 out and make it an absolute value. And I could just factor it out. Let me go ahead and include the steps. So if I factor out a negative 1, it becomes x minus 5 over halves. Absolute value of negative 1. And then x minus 5/2. So y ends up becoming absolute value of x minus 5/2. Okay, so that's going to be a plus 5 divided by 2. So we're going to add, add 5.5, which is 2.5. Let's do it in a different color. 2.5. Right? So it's going to look something like that. Okay. Next graph, y equals, let's turn this back around, x divided by 2 plus 2. Let's factor out a negative 1/2. So that's x minus 4, absolute value, x minus 4. That is also going to be an absolute value, 1/2. That's going to move it 4 to right here. Up 1, 1, 2. Ba-bam. And then we have the 2 intercepts. Okay. Good job. Let's keep going. Let's keep going. Okay. Solve by graphing. So we're going to take absolute value, x minus 3 minus 2. We can solve it first. So I can kind of look at the intersection points. I'm going to change it to this, even though it doesn't say equal to. You can see how to graph it. Plus 2, 1, x minus 3 equals 1, or x minus 3 equals negative 1. That's going to be 4, and that's going to be 2. Okay? Let's go ahead and separate it out. Y equals negative 1. Y equals x minus 3 minus 2. Negative 1. Like that. Now, how did this function move? It moved right 3. And up 2. And we know that this is going to be using these two. It's going to be 4, negative 1. I mean, because y is going to be negative. That's the intersection point. So y is going to be negative 1. 2 is going to be negative 1. Because those are the intersection points. I just realized that my thing is right. Gosh, I must be tired. I'm sorry, guys. It's down 2. Right 3, down 2. It's right here. And then now my intersection points make sense. It didn't before. Now you look to see that the area where the quadratic, I mean not the quadratic, but the absolute value has to be greater. It has to be greater. Right here. It has to be greater than negative 1. Okay? So you know that the answer to that is going to be x is less than that 2, or x is greater than 4. And you could have actually solved it. You know, you could have actually solved it, but that's how you solve by graphing. And you show the graph to 2 different equations, and then you just graph which area is either lower, less than negative 1, or greater than negative 1. Okay. Good job, guys. Okay. Solve by graphing and state your answer. This one, I'm gonna take the time out to actually solve by not graphing. I'm gonna do it algebraically too. So that's going to be, let's go ahead and isolate. So greater than 1, so x minus 3 is greater than 1, or x minus 3 is less than negative 1. And so x is greater than positive 3, so that's 4, which is what I got here. Plus 3, x is less than 2. Okay? Which is what I got when I graphed. Let's go ahead and solve this. Okay, I'm gonna first solve it. And ta-da! My mind is drawing blanks. Less than 1. Multiplied by 2. 2. So x is less than 2. And x is greater than negative 2. Okay. Now that's going to help you out because that's actually solving it. Where I did up here, where I actually solved it. Instead of doing that when you graph, you actually solve the inequality. I'm sorry. I'm coughing so much. And when I break it apart, y equals 3 and 1/2 absolute value x plus equals y, you know that these areas are going to be of importance. So I'm going to look at 2, 3, and negative 2, 3. And where did I get the 3? Because when y is 3. So right here. Okay. And then 2, 3. Right here. And negative 2, 3. And how do you graph this? It's moved up 2. I'm going to use that as a slope. I'm going to go up 1 to the right 2. And it's looking for the areas that's less than. Right here, I can write it as a compound inequality. Less than 2 is greater than negative 2. Okay? Good job. Let's go. Piecewise functions. Okay. So let's go ahead and graph it. So if it's less than 3, so I'm going to pick some points that are less than 3, it's going to be a linear function. Let's actually use 3. So let x equal negative 3. Negative 3 is going to be 1/3 negative 3 plus 2, which is negative 1 plus 2, which is 1. So that's going to be negative 3, 1. Negative 3, 1. And then from there, I could just go up 1 and to the right 3. Okay, but it has to be less than, so I'm going to go down 1 and to the left 3. Like that. Whoa. Like that. Okay. And then I'm going to go between the lines right here. And then that's also going to be a linear function. I'm going to maybe just use 0. Okay, but put a circle where 0 is because it doesn't equal. So let x equals 0. I'm going to put it into the function that it doesn't belong in, but just to help me out. Or I could use 1. Yeah, let's just use 1. Okay, f of 1 equals negative 1 minus 2. Negative 1 minus 3 equals negative 4. So that's going to be 1, negative 4. 1, negative 4. And then the negative 1 tells us to go wait a second. I should have used negative 1. What am I doing? I'm sorry. F of negative 1 equals negative 1 minus 2 equals 1 minus 2 equals negative 1. So negative 1, negative 1. Not what I had earlier. I have no idea. I'm just getting tired. And then we can go, let's see, down 1 and down 1 to the left 1 right here. Put an open circle right there. Down, up 1 to the left 1. Okay. Up 1 to the left 1. There'll be an open circle right there. Okay. And then somebody asked, since there's going to be an open circle there, it's okay. Okay, it doesn't all have to link up. And then from x is greater than 0, it's this parabola. So let's just sketch that parabola. It went down 2, it's going to start there. Okay, down 1 to the right 1. There is the parabola here. Down to, let's see. Down 1 to the right 1, down 2 to the right 4. No. What am I doing? Sorry. It's actually up 1 to the right 1. And then up 2 to the right 2, right 4. 2 to the right, like that. Yeah. Right? 2, 4, and then 2. Negative 1, 1, negative 1. Okay, there we go. And there's just an open circle there. Write the equation of the piecewise function. There should be arrows here. Okay. So f of x, or you can put y, equals, looks like there's 3. Okay. Looks like there's 3. And so let's go ahead and start with the leftmost one. That looks like a linear function. And whatever it is, it's where x is less than negative 2. And then we can figure out using like that point right there. And a good point. I don't see any. Let's just use that point. Okay, so that's going to be negative 4, 2. And negative 2, negative 1. And remember how to find us equations between 2 lines using those 2 points. So y equals mx plus b. Gotta find slope. Remember how to find slope. Slope is y sub 2 minus y sub 1 equals x sub 2 minus x sub 1. So 2 minus minus 1 plus negative 4 minus minus 2 plus 2. So it's going to be 3 of negative 2. So we can check. Went down 1, 2, 3. We went to the right 2, which is what that says. I'm going to use one of the points. Negative 3 over 2. Negative 4 plus b. 2. And that's going to be a positive 1/2. That's going to be 6 plus b. B equals negative 4. So that equation is now going to be y equals negative 3/2 x minus 4 when x is less than negative 2. Okay. The next looks like a parabola, and that goes from between -2, and I can put the close circle there, 1, and it looks like 2, 1, 2. No, A doesn't look like 1. No, is it? 1, 2, 3, 4, 1, 2. No, unfortunately, A doesn't look like 1, but we can go ahead and figure out y equals. It's going to be x, and it's going to be some kind of A. So y equals ax. And the way I could figure out A is to put it some points. For -2. Is it actually? Yeah, I think it's just 1. Just 1x, right? Because if I x squared, because if I put in -2, yeah, it's just, sorry, it's just 1. There you go. And then y equals, and that looks like a linear. And since we didn't put an equal sign there, I can just say x is greater than or equal to 1. And I can use those 2 good points. It looks like slope is just 1 on that one too. Down 1. And so just y equals x. Looks like it's going to go straight through there. Start here, up 1 to the right 1, up 1 to the right 1. Yeah. There we go. Finished. Yes. Yes, yes, yes. Okay. Good job, guys.